Hi, good morning, everyone. Welcome to our municipal BMP show and tell. I'll give everyone just a second to get situated. We had over 50 people registered and we have about 35 on the line now. So we're almost to our critical mass here. All right, so we are recording today's webinar just to let everyone on the line know that it's going to be recorded, and I will go ahead and kick things off and get our webinar started. So welcome to the Pollution Prevention Municipal BMP Show and Tell. My name is Krista Guzman. I am a senior planner here at the COG in the Environment and Development Department. I've been working here for 7 years, and for a fair number of those, I've been working on the stormwater program, and so I'm really excited to host today's webinar on the BMPs for the Pollution Prevention Group. And here is a quick look at our agenda for today. We have speakers from the town of Prosper, the city of Mansfield, and the city of Fort Worth. We will be having a Q&A roundtable at the end, and then we'll share a couple of resources before we wrap up today's webinar. A couple of housekeeping things. Please keep your line on mute until the end of all of the presentations. We are going to save the questions for the end for that open Q&A session. If you would like to go ahead and put a question in the chat throughout the presentation so you don't forget it, that is fine. Go ahead and type it in the chat and we can circle back to that at the end. And then if you also want to at the end raise your hand to speak, that lets us know to call on you for your question. The webinar slides and recording will be posted on the COG's website under the section called NCTCOG resources at the link below. That is the link to the pollution prevention program page, not the committee page, but the program information page. So again, we have James House from the city of Prosper, Julian Holmes from the city of Mansfield, and Kathy Matthews from the city of Fort Worth. So kicking it off today is going to be James House. He is the Stormwater Utility Administrator in the Engineering Department at the town of Prosper. He has been with the town for a little over 6 years. And so I will advance the slides for James today. All right, James, take it away.
Wonderful. Thank you very much. I appreciate it. So basically, I'm just going to get short and sweet and explain how Prosper made our decision to change our silt fence type from woven to non-woven silt fence. So we'll start with the first slide. Basically, everybody knows these by now. On the left, you have the woven. That's your typical fence. On the right is going to be the non-woven. Most of my descriptions I pulled off of a company website, so I'm not endorsing anybody, but they do have some good examples of describing different types of silt fence. So North Central Texas, I'd say all the municipalities that I know of use the woven silt fence. So I'm ready for the next slide. Here are a couple different descriptions of the non-woven and the woven. I felt like this is a good way to start it off, but basically town of Prosper was looking at the permeability of the fence. So how fast is it letting the water through? So your typical woven silt fence is going to do a really good job of holding the sediment and the water back, but it's not so good as letting the water leak through and kind of go through the fence slowly, which is what we were looking for. And so I started down in Austin. I was there for a good 2 years. And this is the type, the non-woven silt fence is what they, Travis County, I believe city of Austin requires everybody to use. So I really liked it when I was down there. I had a supervisor go down and for a family vacation, and he was looking at the fence, and we kind of went over pros and cons and what we want for Prosper. And for us, one of the major issues that we had were after heavy rainfalls, sites weren't dewatering properly, and it was difficult for us to go and check everybody and make sure they had their dewatering bags or different controls, the dissipation pads, to make sure that the dewatering requirements were set. So one big decision maker for us was the fact that there's going to be less dewatering because the water is able to flow out at a faster pace through the non-woven silt fence. So we decided to bypass our typical protocol and prosper if we change a BMP or do something different than what's already in place. Typically, we are required to check with our comparison cities and see what they are doing. Since I knew that none of our comparison cities were using this type of fabric, the non-woven silt fence, we decided to go ahead and make it an executive decision and really just add it to the general notes that this is a requirement for Prosper. So since we decided to make the executive decision, we gave a 2-year educational period. So basically, we had this requirement. We told the sites, we told the erosion control companies, hey, this is coming up. We're going to give 2 years to kind of get into it. And, you know, the thought process with that was try to eliminate a little bit of the pushback that we can get because the non-woven is a little bit more expensive than the woven silt fence. So after our 2-year educational period, let's see, 2023 is when we really started enforcing and requiring all sites to have the non-woven. It was at the point where if they installed woven after we told them, you know, multiple times over the past 2 years that this is not allowed in Prosper anymore, we would make them, you know, remove it and install the woven. And after after you require a job site to pull up all their silt fence, 20,000 linear feet, that's a lesson that they learn. They learn it once and they learn it quick. So it was fairly easy after we decided to kind of draw our hard line in the sand and say, hey, you know, this is what's going on. You know, a lot of the bigger sites, the bigger developers got on board early on. It was more of the smaller developers, smaller sites, and I'd say developers who hadn't worked in Prosper before that we had more of the issue with. But we're at the point now in 2024 where everybody is pretty much on board with the non-woven and we don't get any pushback. Next slide, please. This is just another one. You can see some of the benefits that we really like. I'd say that if you look at the applications for the non-woven, you got the soil separation, you have the filtration, erosion and sediment control. Those were the top 3 that we are looking at. And if on the other side, you can kind of compare it, you know, to the woven geotextile. And it's, I don't know, we found more applications and benefits for the non-woven versus the woven. Next slide, please. So as I said, permeability, less dewatering, and I really like the non-woven because it has other uses. So they can get a bunch of this material. You can make silt fence out of it. It's the same material that's placed under the construction exits, you know, underneath the rock there. You can make it into a dewatering bag. It wouldn't take any chemicals out or anything, but it's good for just the straight soil dewatering. And you can also place it on top of bare soil to help erosion. So you can turn it into an erosion control blanket as well. So that the multi-use also kind of helps. And that's how I kind of sold it off to some of my job sites and say, hey, y'all can, you know, stock up on this or have your erosion control company use it for different things. And so you don't have to necessarily use a bunch of different products if we find that it's effective on a job site. Next slide. So now I have a couple examples. If you look at the bottom of the non-woven fence, you can see it's starting to even like grow algae and some plants and stuff in there. This is all my photos were taken recently after storm events. You see this one is from March 26th. So we had a huge storm and it's been leaking water long enough, slowly. The other side is just about dry. And even when it gets jam-packed with sediment, the fence still, you know, allows that water to settle down to the bottom and flow out pretty effectively. Next slide. Here's the other side of that first picture. So you can see one pushback that we got was the strength of the fence. And the woven silt fence is stronger, But from what I've seen from field application and just use, that the nonwoven is actually able to withstand heavy rainfalls with large amount of sediment. So in this photo, around it, we have some pretty good erosion control blanket. They did some seeding, but upstream, it's a fairly long, this is on the side of a roadway, one of our big road projects. And they had some rock check dams and different controls that blew out during the storms. And you can see the amount of sediment that has run down this channel, and that fence held up. So for me, this is one of the best examples that I have to show is that it really does have strength as long as you have other controls in place to really do a similar job as far as standing up to heavy flows and heavy sedimentation as compared to the woven silt fence. Next slide. Here's another example. This one's actually interesting because it's full, but what I was trying to show here is we have this slope. You have a little bit of vegetation on it, but you can see the little rills starting to form. And even though that the fence filled up and it overtopped, you can see by the dirty, watermarks on the top, it still didn't break. And so this slope, it's a decent slope. There's a parking lot on top, and it kind of goes down. And they're still installing a few things. So they haven't gotten their full vegetation in yet. But this was another example of how it is lasting and how strong it is. So next slide. That was it. Does anybody have any questions?
We can also take questions at the end.
I have a quick question. Oh, go ahead.
Oh, yeah, go ahead.
Okay, so I feel like I may have misunderstood. So in the beginning, you were saying the non-woven is, well, obviously, the woven is more permeable, so it drains more quickly. And so would you say that that's maybe like one of the negatives about the non-woven was that you do have to dewater more often? Is that what you were saying?
No. I was saying actually the opposite. Since it drains more quickly, there's less, less standing water. So that's why we're doing less dewatering. And honestly, that's helped us out quite a bit as far as the amount of dewatering we have. I mean, obviously in a flat farm field, you're still going to have it, but on the sites with more of a slope, I've seen quite a bit less dewatering, and it also helps that soil dry out faster. So when they do need to dig that back, and get ready for the next storm, they can get in there more quickly to dig that stuff out and then restand the fence or replace it if they need to.
Okay, great. Thank you.
And I see Jack Brothers, you have your hand up.
Hi, yes. I just had a question. Earlier, you mentioned that you kind of got together with all the third-party erosion control companies. How do you get in contact with all the third-party erosion control companies that operate in your city to kind of make that announcement of these kind of BMP updates?
In Prosper, we require that all projects send me their third-party inspection reports. So I have all that contact information. And when I send inspection reports, I actually send them to the site contact and the third-party erosion control. And so I already have all that information cataloged and everything. So that's how I was able to reach out to them. And quite a few of them actually call me if they have questions. Or sometimes I'll do ride-alongs if I'm having, like, say, a problem site or something. And so I have a decent relationship with a lot of the major companies that work. It's, like the smaller ones we don't really speak to very often, that you have to reach out to via email. But a lot of them I was able to just reach out when we were doing an inspection and just give them a heads up.
Gotcha. So mostly just any of the third parties that are already existing and working with construction crews that you guys have on site in your city right now.
Yes, sir. Yeah, for us, the major ones are going to be Trinity Green. They do inspections, and Southwest Erosion Control. I got one, right. Bobby Dixon Erosion Control. We have 4 of them really that get a lot of the work.
Okay, thank you.
All right. Well, we'll go ahead and move on to our next presenter, and then if there's any additional questions, we can cover them at the end. So up next, we have Julian Holmes with the City of Mansfield. He is the stormwater coordinator for Mansfield. He's been there since 2018. Prior to that, he held positions as an environmental investigator for the TCEQ and the Air Quality Division and as an 8th grade science teacher. He also holds a Master's of Science in Biology from UTA and lives in Fort Worth with his wife and children. So with that, I will turn it over to you, Julian.
Okay. Can you hear me and see my screen?
Yep, you are good.
So I'm going to share with you our adventure in conducting some maintenance on one of our stormwater ponds. It's a city property. So many of you are aware that the MS4 permit we're a level 3 city with our population being under 100,000, and we're phase 2. So we have the MS4 permit, and our swamp has a requirement that we conduct inspection and maintenance on our BMPs, our post-construction water quality BMPs. So I'm going to take you through this adventure. I'm going to talk about the pond itself, how it was designed. Then I'm going to talk about how I conduct my inspection and what the inspection results look like. And then how we came up with the plan to deal with the maintenance issues, which primarily consisted of these 5 things, which was timing it so that we could take advantage of the rainy season. So we did it kind of right. We did it in October. So we were, the pond was kind of low from the summer. And then, when we were done with the maintenance, we were going to be going into the rainy season and not have to spend money to fill it up. So we pumped down the pond, cleaned out the forebay. We planted some aquatic plants, and then we waited for rain. So the pond itself was designed to provide water quality treatment for our service center that Public Works and utilities operate out of. So this is where we keep all of our heavy equipment. We've got materials bays in the back. So there's a lot of potential for some discharges. And so we're sending all of the drainage into the pond. It was, we started enforcing the post-construction component of the MS4 permit in 2015. And this building was going through design around that time. So this was actually one of our first, is real early on in our program of requiring water quality BMPs for new development. And the pond was designed to treat drainage from the building that exists currently, and then a portion of the new building that's coming in. Actually, now we've actually got some plans in for review now. So this pond's going to be seeing some service extended to that. So the way it was designed was we use iSwim for our water quality. So it was designed to treat the 1.5-inch rain event or the water quality volume. And it was designed with a concrete forebay. So the outfall is submerged, but then it flows into a concrete forebay and then out from that and into the pond proper. It's also stocked. Our Parks Department keeps it stocked with fish, and residents are encouraged to come and take advantage of that. And we've got a place here for them to dispose of their fishing wire. And that helps with the biological uptake and just the general health of the pond. So it's kind of some synergy there that we're providing citizens an opportunity to enjoy it. As far as inspections go, I developed an inspection sheet in a form that we use called iForms. It's the same app that I use on my iPad to do my construction inspections. I just built a separate form for it based off of 2 different sources. One is the iSwim Site Development Technical Manual, and then the other resource is the EPA has a Stormwater Wetland Management Guidebook, and they're the recommendations are very similar. There's mowing. They want you to mow the slopes of the pond and around it, and of course you're checking for dumping and litter and that sort of thing. And then you're checking for vegetation. And there's a recommendation that if there's vegetation is over, I think 50% of the surface of the water of the pond, then you need to start removing it. And I'll come back around to that, to where we landed on the need for vegetation. You're checking for erosion. around the slopes and around the outfalls. And then you're checking the forebay. So iSwim says you should be clearing out your forebay every 5 to 7 years or after you've lost capacity in the forebay, and that's very similar to what they were saying over at the EPA. It's a 5-year cycle, or when 60% of the original volume is lost. But that's difficult to determine how much sediment is in the forebay without pumping down the pond. There is a way to inspect it with a depth rod. So this is what my inspection looks like. I just have this form that I created, and I'm just checking, for erosion, for sediment, for discharges, for invasive species. I don't see any cattails in mine. This is what our pond looked like when I conducted the inspection in 2022. So you can see that there's no vegetation except for maybe some algae that's under the surface there. But there weren't any issues with erosion or sediment discharges or anything of that nature. Just the fact that there's no vegetation. And then there's the issue of the forebay. So here's my depth rod. It's a telescoping Philadelphia rod I got off of Amazon. It's a 16-foot rod, and I use it also to inspect hydrodynamic separators, and it's the same technique. You just insert it into the water column and fill around until you find the top of the sediment pile, and you just make a note of where that is, and then you just drive it down through the sediment and find the bottom, and then you do the math and you figure out how many feet sediment you have in your forebay or in your sump. The forebay does extend out quite a bit, so I'm only really checking the forebay that's here at the head wall, or where the pipe is, right? So I'm really at this point right here, I'm checking sediment in the pipe, not really in the forebay. Now, I did previously try to inspect the depth of the sediment out in the forebay proper. I borrowed a boat from our parks department, and I tried to row out into the pond, but what I found was it was impossible to find the geometry of the forebay. I couldn't feel. I was feeling around with my rod to try to see if I could feel the concrete walls of the forebay, but I couldn't find it. So I didn't know if I was feeling sediment in the forebay or if I was just feeling the bottom of the pond, and the boat kept moving with the wind. It was just impossible. So this is not a perfect forebay inspection because I'm only checking it here but it is a good indicator. So the determination from my inspection was that we needed vegetation and we had sediment in our forebay. And since the building had been built in 2017 and we were at 2022, we were at a point where it needed to go ahead and probably be cleaned out. So my first stab at this was to work with our utilities department and see if we could do this without spending any money on a contractor. So I worked with a crew from utilities to pump the pond down. So they brought over one of their pumps, and we set that up with a kayak that I borrowed from our parks department. We have a Oliver Nature Park, which has got like a public education program, and they do some kayaking in Walnut Creek and whatnot. So I borrowed one of their kayaks as a float so that we could draw the pond down from the surface and continue to move the opening of the hose out as the pond was drawing down. We could move it out and continue to draw from the surface and then not be discharging sediment. So that worked. The kayak worked and it didn't cost us anything. And then we protected the outfall, the overflow. This is actually the overflow structure for the pond. So we were pumping into the overflow structure, which would go through some storm sewer pipe and then out and where it would daylight off site. So we pumped it into a vegetated area and then threw a straw wattle into the overflow. And then I walked over to where the storm sewer daylighted, and I just monitored to make sure there was no sediment being discharged. So that was working well. And then we only really needed to pump it down to expose the forebay, so we didn't need to pump the entire pond down. But before we even exposed the forebay, you can see that we discovered there was quite a bit of sediment in the pipe. And the utilities guys were having some trouble pumping it because it was very compacted sediment. So they had to spray it with water to loosen it up and then pump it out. One interesting side note, I discovered some debris in the pond. There were a few tires, actually about 4 or 5 of them, that had a cinder block wedged inside the tire, and that was just very curious to me. So we have a collection center that we operate, and citizens can bring in tires and dispose of them. So I managed to pull one of the tires out of the muck, and I took it over to our collection center. And Dave, who is our coordinator, collection center coordinator, was here when the building was built. He told me that the guy who stocked our pond for us with fish put the tires in there, and that's what the cinder block was for, was to weigh the tire down. And he did that so that it was to provide habitat for the fish. So I was griping and grousing that who would come to a city pond to dispose of tires and go to that much trouble to weigh them down with a cinder block. I was actually a little more than just a little irritated about it, but he had the institutional knowledge and was able to say, hey, those are actually there on purpose for the fish. So I left the tires in there. So when we were pumping out our sediment and realizing some of the limitations of our equipment, we had this small back trailer that really only holds about 500 gallons, which the volume of sediment in our forebay exceeds that. So we were on our second. We had already unloaded 1 load of sediment from the vac trailer when we realized that there were some other issues as well with our equipment. We got the trailer stuck in the slopes of the pond and had to go and get a backhoe to pull the whole rig out. So after realizing how many trips and how much time it was going to take to empty this forebay out, and the other issues that we're having with our equipment, I don't think that utilities had a 4x4 hooked up to the trailer. It was just, that we had to go and get the the backhoe to get them out. We decided it was time to go ahead and reach out to a contractor. So we did. I don't think I've included any information here about who the contractor is. We're not endorsing any contractors. That's not what this is. I was just sharing so you can kind of have an idea of what the cost was, how much we spent. So a little over $7,000 to have a contractor pump down and clear out that forebay for us. And that's what it looks like afterwards. So I've shown you that picture again, where I did my inspection with the depth rod, and you can see here, this is right where I stuck the depth rod. So you can see that there was quite a lot of sediment coming out of here and then into the forebay. So it really was quite a job, 5 years worth of sediment in that concrete forebay. So moving on to the vegetation requirements, these are details and cross sections from the iSwim Site Development Technical Manual, showing you how a stormwater wet pond is supposed to be designed and with aquatic plants on the aquatic bench. So you are supposed to have a safety bench built in with the design. Just from my own experience of working with development and contractors, they tend to just, design a pond to be just a big giant bowl, and not really, you kind of have to fight with them to get components like this in, where you have a safety bench, or where you have not just like one slope, right? Like to design in irregular features like safety benches and irregular shapes around the pond. They tend to just want to make it easy for their equipment to move in and operate and get the dirt out and get it shaped and move on. But if you can manage to get that bench, the aquatic bench in there, then there's a place for the plants to take root, and that's the goal. And you can see here with an earthen forebay what that would look like, right? You'd have the plants here around the bench, and then basically just right under, because of a lot of the aquatic plants, their roots need to be submerged. So looking for a supplier, we went to Texas A&M AgriLife's webpage. They have a aquatic plant nursery recommendation. They have several different nurseries that you can reach out to. Now, again, the city is not endorsing anybody. So when I'm including the costs here, I have not included the information for who we worked with. You can see where the website is to go and find one near you or who you want to work with. But this is what we ended up spending, was about $1,200. They recommended these 3 different plants and in these quantities: arrowhead, pickerelweed, and American water willow. Now, I'm not a horticulturalist or a naturalist, so I I might not have identified. These are pictures of what the pond looks like today and what the plant life is doing now. So just a disclaimer, I might not have identified them correctly, but arrowhead was one of the species that we got, and I don't know exactly which species it was because there's several different arrowhead species, but it was recommended because it attracts pollinators and its seeds provide forage for wildlife like ducks and things of that nature. You get more wildlife in a pond, it's healthier. It kind of contributes to that biological uptake of nutrient pollution. Pickerel weed was another one that they recommended. It also attracts pollinators and also provides some food for wildlife. And then the third one was American water willow, and it's supposed to help provide erosion control and some habitat. So we planted it while the pond was still low. You can see the exposed slopes here from where we had pumped down the pond. And we had to get into some waders and get in and plant the plants, drive them into the sediment on the slopes. And then we just waited. And this is what the pond looks like now. I just took this picture last week when I was putting the slideshow together. So you can see, compared to what it looked like before, there was no vegetation under the permanent pool. But now it's come along quite nicely. And I saw a lot of dragonflies out when I was taking these pictures. So I think these plants are doing their job, and it's going to be a while before we have to think about removing or harvesting some of the plants. The guidebooks say that you're supposed to remove or harvest the vegetation when it's at about 50% of the surface of the pond, and we're nowhere near it. We're not even at 25% yet. So, but this is all just from, you can see how we planted it, right? Kind of just 2 years ago. We didn't have a ton of it. We just kind of spaced it out and planted it like that, and then 2 years later, it's coming along nicely. I did check the sediment in the forebay at the head wall, and I have about a half a foot of sediment. When I did that inspection in 2022, I think it was at like 1.5 or 2 feet. So it's already collected some sediment. Some of that, though, could have just been from when the pond is filling up. It's going to disturb sediment just generally in the pond. And so some of that sediment that's in the forebay could just have been from the slopes of the pond itself and not necessarily from the runoff. It's hard to say. But either way, we'll be looking at it again in another 3 years from now to see if we need to clean it out again and checking on the plants as we go. Does anybody have any questions?
Yeah, it looks like James has his hand raised.
So I really like your vegetation on the sides. Have you seen that tends to choke out the cattails?
We've never had an issue with cattails in this pond.
Impressive.
So I don't know if you were dealing with a pond that had a historical issue with cattails. I would think that that planting vegetation would be a good strategy because it could, prevent the cattails from taking place. That might be a good question for one of the nurseries. Like, what's a good robust species to compete with cattails? So I don't know if any of these would fall into that category or not, but this pond has not had an issue with it. We have not had to go in there and remove any cattails. So this is what it looks like when they're not having to compete with invasive species. That's a good question.
Well, and Julian, I see you're getting some applause in the chat from Michelle Wood Ramirez.
Thank you. Okay. Well, if you guys, I didn't put my contact information up here, but Krista has it. It's just julian.holmes@Mansfield, Texas, spelled out, .gov. So please feel free to email me if you guys have any questions about our pond.
All right, thank you, Julian.
Thank you.
So next we have Kathy with the City of Fort Worth. And Kathy, remind me, are you going to share your slides, or would you like me to share them for you?
You were going to share it, and I would.
Perfect. All right. I'll pull those right back up. So the slides are loading, and it looks like we do have one question in the chat for Julian. It says, do you have any issues with algae?
Oh, no, not really, not historically. I will say that there was some algae kind of along that aquatic bench before. And I would say that there's probably less now. Um, you know, I don't, but I would, and I would think that the plants, having some aquatic plants would help because that would be taking up the nitrogen or phosphorus. But again, just like with the cattails, we have not historically had an issue with the pond, and the pond really isn't that old, so that might be a factor. And we are also not dealing with residential runoff. This is more or less an industrial facility that we're treating the runoff for, so there's not a lot of nutrient. It would be more about hydrocarbons, I think.
All right, thank you. All right, so our next speaker is Kathy Matthews with the City of Fort Worth. She is a senior environmental specialist with water quality. She has worked with Fort Worth for almost 16 years and has many years of experience in water quality monitoring as well as the MS4 monitoring requirements. All right, Kathy, I'll turn it over to you.
Okay. Good morning, everybody. So we're going to talk today about our one of our floatable control devices we've done in the past couple years. This one's on Lake Como, and it's called a bandalong. So this is Lake Como. Next slide, please. Lake Como is within the Lake Como Clear Fork Trinity River watershed in southwest Fort Worth. You can see there's a pin right there, and downtown Fort Worth is in the upper right-hand corner. Part of the reason we did this, let's talk about the MS4 permit requirements before we go much further on that. Our MS4 permit, MCM1 is maintenance activities, and one of those includes reducing the discharge of floatables to the MS4. Also, our MCN8 has a floatables monitoring requirement that we will collect floatables at 2 sites minimum, and when we collect them, we'll quantify the volume of the waste that we collect on them. So that's the MS4 requirements for this, how we fit this in. Next slide. So the way we did this, Lake Como is a neighborhood improvement project, and the lake itself falls into that, of course. As part of the NIP, we contracted with an engineering firm to do a little litter control assessment on the lake. Some of the other things we did for the neighborhood were we did a water quality assessment on the lake itself. They did some fixing of the dam, which we'll look at in a little bit. They did some code issues throughout the neighborhood, and they did some sidewalks and street fixing as well. I think they did some street lights as well. So as part of the NIP, we did this assessment, and they identified 6 potential sites for litter device locations. And I hope you can see my pointer. I don't know, can you? So they were scattered throughout the lake, basically, where the red dots are. 1, 2, 3, 4, 5, 6. And of the 6 sites, they also looked at different devices, including bandalong, and they looked at water goats, that kind of litter containment device. You can turn. Might have been better, Christy, if I'd done the slides. You can go ahead and change the slide. It was determined the bandalong was the best fit for the lake and for what we needed it to capture, and they selected this location on the northwest side of the lake, and that's the location of the proposed bandalong on the lake. So this the next slide. I kind of go through my slides quickly and then I'll talk. This is what the Bandalong looks like overall. This was not the one that's on our lake right now, but that's just what it looks like. This is the site that they selected on Lake Como on the northwest side. These are the two outfalls that come into that channel on the northwest side. And you can notice a little bit of the vegetation along here. When they went to fix the dam, they drained down the lake and they left it drained down so long they had a lot of weeds that grew where there was no water at that point in time. And so when they refilled or allowed the lake to refill, all this vegetation was inundated, and they had to end up having to take some of this out to get the Bandalong in. So you can see that on the next one, I'm sure. This is the schematic of the device, and so you'll see it's got two arms. One is longer than the other, and then the little capture device is right at the end of those two arms that kind of channel the litter into it. The total cost of the device, after much effort, was $226,282. This is a location or a picture of the lake before we installed it. You can see again along the edges where they re-inundated the lake, and a lot of the vegetation is dead and ultimately had to be removed so we could get this stuff in. So the next slide is pictures before the installation. That's still the outfall area. The picture on the right, the arrow was one that I did, showed where a tributary comes in just downstream of the outfalls. And then the little dotted red line is where they're supposed to put the Bandalong. And so the next picture slide. So this is when the contractor showed up to put the Bandalong in. This is parts of the Bandalong in the picture on the right, on the left, excuse me. And they're looking at it and going, yeah, we're going to need to get all this dead vegetation out of here. So on the right, we have some of our specialists actually got in there along with a lot of other crew from parks, and the contractor got in there to remove the vegetation so we could get the dead vegetation, so we could get the Bandalong installed. And so finally this was installed in September 23, and you can see that they've started the installation. You can see the piles of dead vegetation. In the picture on the right, you can see how dense some of that vegetation was going across the lake, at the top of the lake. And I don't think planning on removing it right now. They're just going to let it naturally decompose. So that's during installation. And this is what it looks like. The next slide. This is what it looks like after installation. This is our Bandalong on Lake Como. And you can see the arms capture the trash as it comes out of down that channel, and it will go into the device, and Parks comes and cleans it out on occasion. So to date, the next slide. I've talked to Parks, and they've had some issues trying to get the collections because of the location of it and how wet it is when they go to collect it. And then when it's dry enough for them to collect it, their crew is just scattered in so many different directions. But to date, they've collected 5 events, and a total of 1,560 pounds of trash have been collected on the lake. The picture here is a picture after the device has been installed, and that's looking at there's a little dock out from the building there at Lake Como. And so looking down towards the dam in the distance, and the lake looks a lot better than it did. And if you look at the next pictures, I've got a before and after picture. The before was June 21, and you can see there's just litter all through here. Now, I'll tell you too, when they drain down the lake to repair the dam, the lake went down so much. We got a litter crew in there, and they were in there for like 2 weeks getting litter out of that lake. Not just litter, but tires. And I think at one point in time, they even found a vehicle in the lake and pulled that out. And so on the right, you'll see May 24. That's a picture. Again, the dam is in the distance, and that's taken from the dock that I showed you a few minutes ago. You can still see there's a little bit of trash that has blown in, but it's not like anything like it was. So we're going to keep an eye on it, and hopefully we continue to see good efforts from the Bandalong collection and getting all the bugs ironed out as far as the collection itself, pulling the trash out of the Bandalong. And that's all I have. Any questions?
Hey,
Krista, you're
Krista, I think your mic is off if you're talking.
Thank you. Thank you for that. So Perry Hartz posted a question in the chat, and he asked, why was the water goat killed? Did that approach not offer the volume of trash storage needed?
I believe it was because of the volume of water that comes out of those outfalls during a rain event. It wasn't felt the water goat would be able to keep up with it.
This is Julian. I have a question. Have you had any issues with vandalism?
We have not. Thank God.
Do you have any signage up for to educate residents?
There is a sign on the Bandalong itself. If you go to that after installation picture, there's a sign on the right-hand picture, and it talks about one more. There you go. On the right, there's a sign right here, and it's got a QR code for information, and it talks about our Bandalong and what it does.
All right. So Heatherford did respond to Perry's question and mentioned that the water goat is still going strong in Fort Worth, just
Yes.
not on, yeah.
Not on that
Honestly.
location. We have lots of water goats in Fort Worth that are maintained on a regular basis, but this is a different litter collection device from our water goats. But yes, indeed, we have water goats all over Fort Worth.
Another question is, how did you fund this? Because 200,000 is a good chunk of money.
Let me think. We had some from we went through MNC, and they allocated money to the NIP, which is a neighborhood improvement project, and we used money from that, and then we also used money from Park and Rec, and some from environmental. It was a collaborative effort, let's just say.
And another question is, how frequently are you maintaining or removing the collected litter?
Yes, it's city funded. How often? We'd like to have it done after every major rain event, but we're checking it after every main rain event. They're doing it as they can after major rain events. Like I said, it's been done 5 times since it was installed in September. We're working towards a goal of more frequent collection. And that's one of the bugs that needs to be worked out still.
Do we have any other questions for any of our other speakers?
I'd have another question. This is Julian again. In how many man hours does it take to clean it out after one of those larger storm events, or just when maintenance is needed?
That's a good question, and I did not ask that of the guy who does it. I would say generally probably 3 to 5 hours.
Okay.
Probably 3.
And how many are in the crew that do the maintenance?
I would have to find that out for you, Julie, and let me do that. Okay.
I'm just wondering, what the maintenance costs are and how much it costs to
I
just
understand.
doing an estimated on the man hours.
Okay, well, if there's no other questions, we can go ahead and move on and wrap up our webinar for today. I did want to cover a couple of resources that may be of interest and use to our group that are on the line today. So just as a reminder, we do have the Stormwater BMP library on our website. It's organized by general topics, which makes it easier to search for specific items for your individual situation. We also have the iSwim program and website. The resources webpage includes videos of previous training events, information on iSwim certification for our interested communities, and an iSwim criteria community inventory map. So local governments can review the program guidance, criteria, and technical manuals prior to submitting a certification. And we also have our Water for North Texas online library. So this library does contain resources on multiple different water topics on the regional, state, and national level. We have social media toolkits on here, case studies from the COG region, educational pamphlets, videos, and more that can be shared. And then also specifically for the pollution prevention group, a couple of resources that collaboratively we've all developed together, such as the online training portal for the pollution prevention videos. You can find those on our website. And then also the monthly pollution prevention reminder messages with infographics that we just completed earlier this year is on our pollution prevention information page as well. And so with that, I'll wrap up our webinar for today. Just a reminder that the slides and recording will be posted to the COGS website on that pollution prevention information page under the NCTCOG resources section. You can find it there. In the coming couple of days after this webinar concludes, follow-up emails will go out to all registered guests for today. If you were joining today, but you did not register beforehand and would like to be added to this follow-up emails, please reach out to me and I'll get you added on our list for that and make sure that you get a follow-up email. And with that, I'll end here on our contact page for the COG for all of our different stormwater programs. I work on the RSWIM, PTF, and P2 program. Casey Cannon works with iSwim, IDDE, and stormwater monitoring. And so if you have a question about any of those programs, please feel free to reach out to Casey or I. And I want to say a big thank you to our speakers today for taking time to prepare their presentations and share the BMPs that they're implementing at their city and share their experiences and lessons learned with us. We appreciate their time. And thank you everyone for taking time to join us today. See you guys next time.